Hi friends, how does a computer actually boot? How does a processor suddenly come alive and talk to its devices, like your keyboard? What even is a bootloader? And could you write the smallest possible operating system yourself, maybe in just a few bytes? And will we be able to draw graphics onto the screen, for example hearts, in that small operating system? What is assembler? What is machine language? And how does it help you understand what's going on the lowest level inside a computer? In the next 5 minutes, we'll answer all of those questions and see how they are connected, right from the very first clock tick. To understand the boot process, we need to go back to a time where floppy disk ruled. These little guys held only 720 kilobytes, and the data was split into tiny slices, sectors of 512 bytes each. So when you boot your computer would first load the first sector, yes, the first 512 bytes, into the memory and execute it. It would then load other sectors and execute them in a staging manner, but that is a matter for a separate video. However, it does check for the boot sector's signature first. The last 2 bytes of the boot sector must be 55HH in hexadecimal. And still today, the BIOS lets you decide whether you want to boot from hard disk or from other media, in most cases, for example, a USB boot stick. Here I have written a small assembler program to fill the 512 bytes of the boot sector. The interesting part is here. It is a loop that loads a character, prints it, and then jumps back. It also checks the character if it is 0, and if it is 0, it just jumps out of the loop and the loop will end. So what is being done here? The legwork is being done by int 0x10. That is a BIOS interrupt, and that just looks into the processor register AH, and it will find an E here because I have put it in here. So it knows, okay, my job is to output a character, and I will output the character from the processor register AL, and AL has been loaded to be the first letter of this message. Then it iterates and takes one letter after the other and outputs it. Now let's compile this guy. I'm using the Netwide assembler for it. I'm using the binary format. So I'm not doing it for Linux, not for Windows, not for macOS. We don't have support from any operating system because we are in the boot sector. I called it booty.asm, and why I put this Y at the end, you will soon see. And the output shall go into booty.img like image. So we have a boot image, and I type enter. I don't get an error message, so this has succeeded. So I say dear booty.img, and I find it has the length of 512 bytes, so exactly the length that a boot sector should have. Great. Let's have a look at this guy. For this, I have installed HXD, which is a hex editor. It shows me in hexadecimal writing what a file really consists of for each byte. So let's open boot.img, booty.img, sorry. So here we have it. It is called booty, and it is a disk image file because it has the extension img. So I say, okay, open it. And here we see the 512 bytes it contains of. Here we see it hexadecimal. Here we see it as a character if it can be written as a character. If it cannot be written as a character, we just see a dot here. So these are 512 bytes. You see 16 here and 16 there. We see that was quite a long text in assembler, but here it has been compiled to machine code, which is much, much shorter. And it is a bit disappointing. We've wrote so much, invested so much brain power, and now it's not even half of the 512 bytes. However, the boot sector signature, 55AA, is written down here. And just for your information, 55 in hexadecimal writing as an ASCII sign is a capital U, as you can see here. So let's boot this guy from a virtual machine. For this I have created QEMU, which allows me to emulate an E386 machine. Okay, let's start the image from it. It boots from it, and it says welcome from the Bootsector. And some of you will feel reminded of the old days where we had E386 computers which always started in text mode and so on. And indeed, also here we only have text mode, only letters, only characters, no graphics. But what is this? I see hearts here, 3 hearts. Why this? Because of a specialty in my code that you can download from GitHub. I have redefined the Y, the bitmap, how the Y is being displayed to look like a heart. So this way you have 256 letters that you can redefine to look like graphics on your screen, even though you are in text mode. And that is where your creativity starts. You can make the processor print text, draw pixels, even redefine characters. That's not an operating system yet, but it is the moment life begins inside the machine. So in this video, we created a program in assembler that is self-sufficient. It does not need any help from operating system. No libraries, nothing. We wrote code in assembler, converted it to machine language, and used it in place of an operating system. In the next video, we'll look at how keyboards work on this level. But now I am curious, what brought you here? Are you a student, a nostalgic, or a tech enthusiast exploring the machine's soul? Tell me in the comments, and don't forget to subscribe for the next chapter of Programming Philosopher.